Okay, so I wanted to do one problem from CPM. I think it's problem number 76 in chapter 3. And it's about the dog. And the dog is dragging the glass away from the table. And they give you a lot of information in here. Basil's mouth is 12 centimeters above the floor. The table is 72 centimeters high. There's 250 centimeters of tablecloth between Basil's mouth. And Basil is backing away at a rate of 15 centimeters per second. This is a related rates problem. It's also one that's more complicated than something you're going to get on an AP test, but it still is a good opportunity to model and try to do a tricky problem or try to understand how a tricky problem is done. So I'm going to say that I need an equation. I need an equation to start with to differentiate. What I know is that in this model, I'm going to call x the distance from the glass to the edge of the table, and I'm going to call d the distance that the dog has backed away from the table. I'm trying to get my triangle right. There, my triangle is right. And so if I want an equation that relates them all, well, I can use Pythagorean theorem and say x plus the square root of 60 squared plus d squared is equal to 250. Or maybe we want to have x by itself, and you can say x is equal to this 250 minus the square root of 60 squared plus d squared. And then I'm going to take the derivative of the whole thing with respect to t, so I get dx dt is equal, 250 is a constant, so that's the derivative of that is 0. So I'm going to get negative 1 over 2 square root of what's inside, 60 squared plus d squared. And on the top, I'm going to have a 2d, that's the derivative of what's inside. And I'm going to have to also multiply this by dt, or if you'd rather go with primes, which I'd rather go with primes, I'm just going to call that d prime. And so now we have some things we need to figure out what goes where. For one thing, they tell us, what do they tell us? They tell us that d prime is equal to 15. So I'm going to solve this. And then we also can figure out what is d. At the moment that the glass reaches the table, then the hypotenuse is 250. So you can do 250, like to find out what d is, d squared plus 60 squared is equal to 250 squared. You can solve that, and when you do solve that, you get that d is equal to 242.69. And then you plug that in for this d here, and for this d right here also. It's getting a little bit messy there. But so ultimately, the equation that gives you your speed is going to be x prime is equal to negative 242.69 times 15 divided by the square root of 60 squared plus 242.69 squared. And when you do that and put that into Desmos, you get negative 14.56. And you have to, of course, add your units to it. So what are my units? What is dx dt? Dx dt is a speed. That means it has to have distance, and it also has to have time. The distance we're using is centimeters, and the time we're using is seconds. So the question that everybody was asking, exactly how fast was that glass moving the second it reached the edge of the table? The question that preempted, what am I going to do about all the broken glass on the floor and the dog that doesn't behave well? The answer to that question is negative 14.56 centimeters per second.